Yeah. Okay, perfect. So, so this is a data, our actual data, and this data is stored in the somewhere in the memory, and that memory is referred by this particular variable. I'm using this variable to work with that particular data. I'm using this variable to work with this particular data. Now, while working, so the type of the data is it's very important. What type of data it is, that is what integer, because Java is strongly typed programming language. Index equal to 10. Right. So here, like how we have integer, we have different kind of data types. We have to deal with different kind of data. We can deal with the integers. We can deal with the decimal values. We can deal with the character data. Right? We have different types. What are the different data types that we have in Java? Okay, let me open a simple diagram where I have Java data types. Okay, so this is what data types we have. Okay, in Java we have different kind of data types, primitive data types and non-primitive data types. Okay, so these primitive data types are inbuilt data types. Okay, that comes along with what uh, your software. And there are non-primitive data types. These are known as derived data types. Okay. Uh, these derived types can be created. The programmer can create these user defined types with the help of a class or with the kind of array or interface. Okay, with the help of this we can create user defined types. Okay, we'll talk about them later. Non-primitive data types. Focus on the primitive data types. When you look at the primitive data types, we have numeric data types and non-numeric data types. So when you say numeric data types, it deals with the numbers. Okay, it deals with the numbers. When you say non-numeric, so it doesn't deal with the numbers. That's it. So non-numeric, if you look at, we have characters and Boolean, character type and Boolean type. Okay, so and here when you come to numeric, again we have two kind of data that we deal with. We deal with completely integral values and floating point values, where we have decimals and all. Okay, so here if you look at, we have different types. So numeric type and non-numeric type. So non-numeric type we have char and Boolean, and a string is also like available by default, so which represents a group of characters, whereas this characters type represents only single character type, single character values. Here the string is going to hold multiple characters. Okay, if you look at numeric and non-numeric, numeric is again have two things, integral and floating point values. Okay, what are the different again, what are the different integer types and what are the different floating point data types? This is just high level categorization, right? But when you speak with respect to the actual data types that we use in programming, that's a different thing. Okay, um, let me open it. This about sizes, it talks about the sizes. Okay, so this already opened it. Where is the image? Second, let me open the actual. Come on. Somewhere I have captured it, but it's missed. Okay. Yeah, got it. Okay, so here is my image. Okay, you can understand the complete data types in Java. Okay, so primitive types. If you look at integral types and okay, and integral type and floating point type, and non-numeric types, character and Boolean. Okay, so if you look at the integral data, we have these types: byte, short, integer, long. Okay, integer, In integer type, we have byte type, short, integer, long. And when you look at this floating point type, we have a float, we have double. We have float and double. Character data, to represent the character data, we have a type called char. That's it. And for Boolean, we have a Boolean, small b. You have to make a note of it. This is small b, all small characters only. Because Java is case sensitive language, you have to ensure that small letters, capital letters, okay, while you are using it. So these are different primitive types. And non-primitive types, yeah, class, interface, array, strings, all these are non-primitive types. It can be considered as non-primitive types. These are user defined basically, okay, either as part of the software or as part of the user defined. Okay, we can create our own class, we can create our own interface. Okay, in that case the class object is going to be a separate type. Okay, we can create a string object that is going to be separated type. Okay, those are non-primitive types, those are considered as non-primitive types. So do you understand this chart? So data types, primitive and non-primitive. So primitive are like built-in types. Okay, built-in types, those are not user defined, not driven, any driven based. Okay, those are available by default, but user defined, we are going to create it. Okay, come back to let's see an example of it. Okay, so let me take the same example, basic test.java. I think I have saved here test.java. In the source I have test.java file, so let me open the same. Right, so this is what we used yesterday. Okay, so I can work with the integral first. Okay, so integral types. What are the different integral types that we have? I have byte be equal to 100. I have short and integer, and I have long. Okay, so these are the different integral types that I have. Correct. If you look at the image, so these are byte, short, int, long. So I am just keeping the same order, right? Byte, short, int, long. The reason because so this is going to separate it based on the sizes. Okay, byte is going to take one byte of memory, whereas short is going to take 2 bytes of memory, whereas integer is going to take, okay, 4 bytes of memory in Java, and long is going to take 8 bytes of memory in Java. Okay, 1, 2, 4, 8. So sizes wise, why do we need these sizes difference? Why do we need these differences? The similar way, if you look at float is going to take 4 bytes of memory. Your double is going to take 8 bytes of memory. Okay, and if you look at the character type is going to take 2 bytes of memory in Java. Okay, this is a memory space it occupies. When you declare one integer variable, it's going to allocate 4 bytes of memory. It's going to allocate 4 bytes of memory, meaning that what 32 bits it is going to allocate. 32 bits it's going to allocate. Okay. Now, why do we need these differentiations? Let me explain you that. Okay. Say for example, you have $100 with you. $100 with you. Okay, simple concept. Just let me put in a simple way. Okay, you have $100. So to store your $100, okay, to store your $100, so your wallet is enough or not? Your wallet is enough to store your $100, right? So this is what you are storing in your wallet, right? You have $100 in your pocket basically. Just imagine that you have you have $1,000. You have $1,000. Maybe still your wallet may support, and you can keep the $1,000 in your wallet. Just imagine that you have, okay, $100K, $100K. Then is it possible to keep all $100K in your wallet, a small wallet that keeps you in your pocket?
No.
It might be difficult, right? Carrying out, right? So then you might be looking for some better storage. Might be looking for better storage. Imagine that you have, okay, imagine that you have $10 or $100 million. You have $100 million, okay, to store this $100 million. So your wallet is enough? No, right? So you are going to store this maybe in a bag, or maybe in some other big container, right? Definitely you are going to store this in some other bigger container or not, because it's $100 million, and your wallet definitely is not going to support it. Yes or no?
Yes.
Correct. So then we will be looking for a bigger container to store this wallet. Now, is it a good idea? Is it a better idea to store your $100 in this big container?
No.
You have only $100. You wanted to store that $100. Is it a good idea to take this much bigger container? Maybe bag, or maybe more than that, a bigger container. Definitely, it's not a better idea, because the $100 is what, a simple, like one or two. It doesn't need much space. If you to store this $100, if you are going with this much bigger container, it's waste of your memory, right? It's a waste of memory. A similar way here. So depends on the data size, depends on the data size, depends on the data size. You choose the respective data type. You choose the respective data type. You have only value. You have a value of 150, and you wanted to store this 150. Then, so to store this, to store this 150, how many bits I need? So how much value it is? It is simple value, right? It is simple value. And how much memory it is required? Like very less memory. And at the same time, you have a bigger number. You have a very big number. So to store this number, so we need a large memory. We need a large memory to store this much value. So that is what. So that is where. So to use the appropriate containers, as per the data value, we have different kind of data types. Even in the integral types itself, we have four types in the integral itself. Right? We have a byte. So you use the byte if your data is within the byte range. If your data is within the byte range, then you go with this byte data type. Okay, that is what from 1 to 128, right? It's about what, 128. That's what there is a size, not actually 128. It is going to cover the negative values and positive values. Okay, so and if you go to short, it is going to take 2 bytes of memory. So it takes 1 byte of memory. So if your value, to store your value, 1 byte is enough, then you go with byte data type. To store your value, it requires 2 bytes, then you go with the short. Your value is still bigger value, then go with the integer. It takes 4 bytes of memory. Right? So even it is bigger more than this, then you go with the long. The long is the last type to represent any integral data. Okay, 8 bytes of memory. So you have to choose based on your data. Now in our example, I have 100 value. To store 100 value, so it is definitely not a good idea to choose long for that. If you choose the long, you are going to waste the memory. You are going to waste the memory, because the 100 can be placed within the byte itself, within the byte range. Then what is the point of going with the short? not required. Okay, so anyhow, just let me print all these things. System out println, so I can print B. Of course, it's absolutely nothing wrong. It will work. All will work. So nothing wrong in this. Byte, short, integer, and long. But not recommendable. So I have already told you like what is a recommendable and what is a rule. Rule is that you must need to follow, and recommendable is like it's a best programming practice to follow. All right, so I'm getting into the place where I have saved my Java file and I'm compiling my Java file. What is that? Test.java. Java C test.java. Okay, there is what I have missed. I have missed all semicolons. In Java, every statement must be terminated with what? Semicolon. That's important. Compile it, and it's compiled, and execute it. Of course, it executes. And all printed 100, 100, 100, right? So meaning that it accepts. No issue with that. But memory wise, if you look at the memory wise, you will be wasting the memory. Just to store 100 bytes is enough. Then what is the point of going with this, right? So that is all about. That is all about. So you have to choose appropriate data type as per your data. First thing, what kind of data it is. Then the second point is look at the sizes. Okay, so I have another representation where where it talks about the sizes. Okay, so here I have a list. You can see this. Okay, we have all these data types. Okay, look at the integer. So here I have integer. Okay, so integer is a 2 complement integer. So if you don't give any value, the default is nothing but if you don't provide any value, is it going to give any error? By default, the default value of integer is 0. By default, the default value for integer type is 0. For long, it is 0. Short is also 0. For byte is also 0. For all integer types, all integer types. Okay, what is the default value? Integer and long, all the default values are 0. For integral types, the default value is 0. Now, if you look at the sizes, okay, if you look at the sizes, so the size is range of values minus 128 to 127. The byte size is minus 128 to 127. And if you look at the sizes of short, okay, it's a 2 bytes stuff. It's a 2 byte stuff. So here you can see minus 32,768 to 32,767, meaning that it's the range of this is minus 2 to the power of, okay, what is that? 2 power 5, 32, 2 power 6, 64, 2 power 7,
128.
128. So minus 2 power 7, is that 2 power 7 or 2 power 8?
Oh, I'm sorry, 2 power 5. Yeah, 7.
7 only, right? So 2
Yeah.
power 5 is 32, 2 power 6 is 64, 2 power 7 is 128. So minus 2 to the power of 2, 7 to, okay, 128, and plus 2 to the power of 7 minus 1. This is what the range. Okay, this is what the range. This is what the range. Okay, now if you look at the short, right, so this is going to be this 7 in the sense like 0 to 7, 8 bits. The similar way, so it is going to start 2 bits in the sense 2 8s are 16, right? So it's going to start with 15 minus 2 to the power of 15 to, okay, plus 2 to the power of 15 minus 1. If you calculate this value, okay, if you calculate this value, you are going to get the same stuff. This one, okay, minus 32,768. You are going to get the same. The similar way, integer, it is going to be like 4 bytes, right? 4, 8, 32. Minus 2 to the power of 31 to plus 2 to the power of 31 minus 1. The range is basically, we are not going to use this anyhow, like in the numbers wise or in any other manner. but just to have some knowledge. So when you are defining, when you are assigning a value, how big it is, So if you wanted to store 50,000, if you want to store a 50,000, then short is the not the recommendable data type. You have to go with integer. That's all about. So you have to check the number. If the number is like going beyond this number, then you have to use long. So it is going to like support this much bigger number, and hopefully there is no more bigger numbers than this in our uh, real-time world. Okay, so that's all about the sizes. Sizes are very important when you are taking the values, when you are declaring the values. So let's understand one example here. Okay, so test data type. I'm just taking another file to play with this. Let me save this test data types.java. Now what I wanted to do is I wanted to, so byte B, right? I wanted to give 200. Okay, I wanted to give 200. Now compile this and see how and what happens with this. Java C test data types.java. I'm compiling it. So while compiling itself, it is giving error, right? What is that error? The error is saying that possibly lossy conversion from integer to byte. But you are trying to assign a bigger number, and you are trying to assign a bigger number that is not in the range of byte. So probably you are going to lose some data. There is the overflow concept, so the data is going to overflow and you will be losing the data. So this is not allowed. You have to use as appropriate data type. You have to use appropriate data type. So here instead of byte, let me use short. Okay, short is going to take 2 bytes of memory, so it is happy now, so no errors. Understand?
Yeah.
Okay, so you just give a try with 128 also. 128 is also out of range, right?
Yeah.
It is
It's
also out
secure.
of range. 128 or 127? Oh, it is a short,
It's
right?
short.
So, this, so it's saying that incompatible. Okay, logic conversion. So that is what you have to use appropriately. The same thing applicable for short, for long, everything. Okay. Now, however, there is a concept of typecasting. I'll come to that. Okay, I'll come to that. Now, let's understand about the other types. We have floating point types. Okay, we have floating point types. Floating point types. What are the different floating point types? I have float and double. Float and double. Okay, float takes 4 bytes of memory, whereas double takes 8 bytes of memory. So this is to represent the decimal values, floating point values. This double type is going to use to represent. Okay, it looks like both are same, right? So 10.5, 10.5, right? There is no identification that 10.5 is a float or a double. So both are going to work, right? But to separate it, to identify, okay, this is a floating point value or this is a double value. For that, so we have a special suffix called f. Okay, if you give the suffix as a f, that is going to treat that as a float type. If you don't specify anything, by default, that is going to consider as a double type. Okay, now see that. Let me print this system dot out dot println. So I'm just printing f value. Let me print d value as well. So is it going to work or it gives any error? Okay, so just go to command prompt and recompile it because we modified the source. Oh, come on, I missed the semicolon again. save it and compile it. Still I have error. What is that error? Something is expected. Oh my bad. So here also I missed semicolon. Okay, now it is compiled. Now you can execute it also without having any issues. 10.5, 10.5. So this is of type of float because it's suffixed with f. If it is not suffixed with anything, then it is a double. Okay, why I'm saying this? Yeah, while you are typecasting, this is important. Okay, so we'll discuss the typecasting soon. Okay, so these are floating point values. In a similar way, and we have looked at integral types and floating point values, meaning that all numeric types. So we just seen all numeric types. And what else we have? So numeric types, integers and floating point. And non-numeric data types, what we have? Character and boolean. So these are to represent a single character. So you can use single character here. Okay, so character, so using single quote. Okay, you can use single quote here. I'm just going to print this character. And boolean, we have a type called boolean type to represent boolean values. Okay, boolean values are the purpose of boolean values are, okay, to declare a value to represent like either yes or no kind of answers, or to represent such kind of things. So something like that. Okay, is that customer allowed for that offer? Is the customer is having that offer, or do you have validity still? Are you married? So these kind of things, right? So these kind of things you will be answering like either yes or no. So to represent these kind of data types, to represent this kind of data, we have data type boolean. So the allowed values are true and false. The allowed values are true and false, only these two. If you try to give anything else, it is going to be error. Okay, it is going to be error. And all are small letters. All are small letters. That's what you have to see. Okay, so here is boolean b, and I have b1. Okay, these are the non-numeric data types. These are non-numeric data types. Just compile it.
Semicolon.
Okay, so but where I'm missing semicolon. Okay, yes. Okay, so compiled with no issues, and it's printing m, true, false, all the values. So this is how you can declare these types and you can make use of it. Okay, and if I wanted to represent a group of characters, not a single character, I wanted to represent a group of characters, that is where we can make use of this derived type string. This is a string, not the built-in type. This is not known as a built-in type, but we use like we use string like anything. Okay, the most commonly or widely used data type in programming language, of course not in Java, any programming language, the string is the most widely used data type, where we represent group of characters. Okay, so this is what a string, this is what a string, so you can use this type as well, string type. Okay, this is what string type. I need to recompile it because I modified the source, so it's printing it. Okay, this is another type. Okay, so these are the different types that we have. Okay, integer, long, byte, short, float, double, boolean, character, and then string. Okay, so these are the different types that we have, and there is a concept of typecasting. There is a concept of typecasting which is very important while working with the program. Okay, any program. So typecasting, there is a concept of implicit typecasting and explicit typecasting. Okay, there is a concept of implicit typecasting and explicit typecasting. When you are working with when you are working with this compiler, a compiler is going automatically cast into the specific type. If it is fine to cast it, meaning that if it doesn't find any issues while casting or due to casting, it typecast it. Okay, it will typecast it. Otherwise, it gives error. We need to explicitly typecasting it. Okay, the first point is, why do we need the typecasting? Okay, why do we need the typecasting? Say for example, okay, say for example, you have a byte value, byte b equal to 100, byte b equal to 100. For some reason, for some requirement, you are going to store this value, or you are going to copy this value into another type of integer. Okay, integer x equal to b. So I'm assigning this value b. I'm assigning this value b to integer. So is it allowed or not? That is what the point here. So is it allowed or not? System dot out dot println of what? I'm printing x. So is this allowed or not? So there are requirements comes up, okay, where we need to assign values from one value with another.
Yeah,
All right. So is it work or not?
yeah, it will work.
It will work. It will work. So Java C, casting example. Is there any error? No, semicolon accepted. That is fine. Go back and see. Okay, now it's allowed, and of course it will work without any issues. Okay, 100. Now let me do the reverse. Okay, let me do the reverse. Say I have integer variable here. Okay, I have integer variable y, where I have a value of 200 or something, or same 100. Now I wanted to convert this into, I wanted to assign this to a byte variable. Say b1 is equal y I'm assigning. Okay, now same thing, I'm trying to print it. I'm trying to print this value here. Okay, so b1. So b1. Now go back here and compile it. Can you see now? So it's saying that incompatible types possibly lose the conversion from int to byte. So it's all about the containers concept, guys. So see, for example, here. Okay, so these are my data, my ranges, right? Byte, short, integer, long. Now I stored a value. I stored a value. So I stored a value in byte. So assume that your glass is filled up with full of water. Okay, full of water. Now can I move all this water into integer?
Yes.
Is there any issue in moving this?
No.
This glass can accommodate all this water, right? Whatever I have in byte, it can accommodate it. Just imagine the reverse. Just imagine the reverse. So I have integer where all of my glass is filled with water, full of water. Now if I assign this, or nothing but assignment is nothing but moving all the water into this particular glass. So is it going to work? Yes, you can fill the water till this glass is filled up, right? And what about the remaining water? You will be losing, right? The water will be wasted. So this cannot accommodate all this water, correct? So that is what error it is saying that. So this is of type integer type. So this is a bigger range, bigger container, and byte is a smaller container. When you move the data from bigger container to smaller container, so there is a loss of data. There is a loss of data. There is a chance of losing the data. Why the noise is coming? Okay. So there is a loss of data. Now imagine the case, okay, imagine the scenario where I have the water only this much, not fully. So okay, it has data only up to this. So this much is capable of moving to this glass or not, meaning that, so my glass can accommodate this much of water. I know that. I know that when I know, even though the container is big, but the value inside that container is within the range of my other container, then I can happily move this. I know that, but compiler doesn't know that, because compiler always look for the types. Boss, integer is a 4 bytes and a byte is only 1 byte. You are trying to move 4 bytes value into a 1 byte value. You will be losing the data, so I don't allow. That's what compiler is very strict about that. But I know that, boss. So even though it is a bigger container, but whatever the value I have inside this is within the range of byte, so I wanted to move it. I wanted to move it. Please allow me to move it. That is what typecasting. So we are going to convert this into this particular type. That is what typecasting, and this is the explicit typecasting. We have to do it. We have to do it. This is what explicit typecasting. This is what explicit typecasting that we have to do it. What is implicit typecasting? The implicit typecasting is moving this byte data into integer. So you are moving the data from smaller container to bigger container, then there is no problem. There is no loss. There is no loss of data. Then what is the complaint? So compiler automatically does that. Compiler automatically does that. So that is what implicit typecasting. So here we have implicit typecasting and explicit typecasting. If you look at the code, so here byte b assigned into integer. So here it is called implicit typecasting. This is what implicit typecasting. So here this doesn't allow. This doesn't allow. But here, what is the value I have? I have a value of 100. I have a value of 100, which is within the range of byte. Which is within the range of byte. So I am sure that. So there is no issue. I am not going to lose any data. Compiler, please typecast this into byte. I know, I'm aware of that. Please typecast this. So that's what explicit typecasting we are doing. So y is integer type. That integer I wanted to convert into what? Byte type. I wanted to convert it into byte type. That's what happening here. So just go back to command prompt and recompile it. Of course, it is happy now. Compiler doesn't have any issues because you are explicitly typecasting it. It thinks that okay, you are aware of that conversion, and okay, there is no possible loss of data, so it allows and it prints it. Okay, this is what called explicit. This is what called explicit typecasting. This is what explicit typecasting. Implicit typecasting and explicit typecasting. So this would require, when you are working with the certain requirements, we need to typecast from one type into another type. But that when you are casting, the types must be supported. The types must be supported. Meaning that what? Say for example, I have a Boolean value b equal to true, and I have a integer value x is equal to index. So can I do this conversion? Can I convert this into integer? Either explicitly or implicitly. So what I'm trying to do here, I have a Boolean value, I'm trying to convert it into integer. That's what I'm trying to do. So now if you see, okay, there's a different error of like already defined this b and all. Let me take b2. The x is also already defined, so let's take a different variable. Okay, it's compiled and it's working fine. Okay, now let me print the value of it. System not out.println of. Okay, when I convert this into integer, how it is going to convert? Is it going to convert into 1 or 0? Never see typecasting example. Oh my bad. So when I'm converting, something I did wrong, right? B2 I have to use. Okay, B is what? B is a byte value, and you are converting into integer. That is fine. But now B2. Okay, so now look at this. Okay, we have used that's what string why it is working. Okay, so now you can see that what error you are going to get is incompatible types. This is what the error I was looking for. Incompatible types. So Boolean cannot be converted into integer. Boolean cannot be converted into integer. So while you are doing this explicit typecasting, you have to make sure that you are using proper types. You are doing that casting in proper types. If you try to do in improper types, you are going to get the error incompatible types. You are going to get the error incompatible types. That is what important. Okay, now so I can do the conversions between what? So I can do the conversions from byte to short. I can do, right, because all these are same types, right? Short to integer I can cast it, integer to long I can do it, right? So this is what byte to short, short to, this is a upward direction, right? So this is what implicit typecasting, this automatically happens. But the other direction, so long to integer, okay, long to integer, integer to short, short to byte, this is a reverse direction. So bigger container to smaller container. This is what explicit casting. So here we require explicit casting. So here it does automatically. That's what implicit casting. Implicit casting. Explicit casting, implicit casting. In the similar way, we have float and a double. You can move a float value to a double because those both are same type. Only difference is the sizes. Okay. So this is float to double implicit, and double to float is going to be what? Explicit. Explicit casting. Okay. So this is what, if you see, one is widening and the other one is narrowing. Okay, one is widening, so the implicit casting is what? Just going to be widening concept. We call it as this. We call it as narrowing. Okay, just we are reducing here. Here we are increasing it. Okay, the sizes. So float to double is possible. Double to float is possible. If you look at this, all is numeric data only, right? Numeric types only, right? Integers and floating point numbers. All these are numeric data only. And if you look at the Boolean and char, they are non-numeric types. So it's 100% possible the conversions between integral types to floating types. Okay, integral types to floating types conversion is also possible. Floating types, vice versa. Okay, vice versa is possible. This is possible. This is possible. Meaning what? Meaning what? So long to float you can convert. You can convert this. You can typecast long value into float value, or long value into a double value. Okay, or integer to a float value, integer to float value, etc. So you can do all these castings. You can do all these castings. Okay, you can do all these castings. So basically, if you look at the chain, so it's a bidirection. Okay, it's all bidirection. Long to float, float to double. Okay, it's all in bidirection. So you can do these conversions. Hope you understand. Okay, so the typecasting is one of the important, very important concepts. You must be having clarity about this. Okay, so you can do the conversions like anything with one with another. Okay, the other type is Boolean. Boolean is not supported to convert into any other format, but however we can use character. Okay, character can be converted into integers. Character can be converted into these types. If you see how, okay, let me comment this particular piece of code because this gives me error. What is the multi-line comment in Java? This is how we can represent the multi-line comment. Now what I'm doing is I'm going to take a character, say for example a I'm taking. Okay, I'm taking a a. I wanted to convert this into some integer value, integer character value. Okay, so now I wanted to typecast into what? Integer. What I wanted to typecast? Where is my variable? Let me take the variable name here, ch. Okay, I'm just typecasting this into character. Now print this value and see. So CHV, what it is going to print, just observe. Okay, all this is for our understanding we have written. Let me keep this whole thing in a comment. This is kind of documenting for our reference. Okay, go back, compile it. So there is error, still I missed semicolon somewhere. Okay. So as I'm working in multiple technologies, okay, so there is a little confusion with that, guys. The scripting language doesn't require the semicolon. Okay, so that's where the confusion. So nothing else. So Java C, Java typecasting example. So what is the value of this here? 97. So 97 is that value, right? This is all about ASCII representations from character to ASCII numbers, right? So that is going to convert, okay, the equivalent ASCII one. So you have a integer number, okay, integer I1 is equal, okay, integer I1 equal say some number 105. Now if you want to convert this char, if you want to convert into this char, okay, you can do it. I want to typecast this in, but it is a explicit casting, okay, because the containers are different, sizes are different. You are moving 4 bytes to 2 bytes container. So char, so I wanted to convert this I1 now. So you just print this system.out. So here I wanted to print character 2. So 105 is my integer value. Now I am printing this character 2. Okay. So ch2 is equal, just for our understanding. Go back. Come on. Right, it's compiled. Let me execute it. So what is the equivalent value? It is I is the equivalent value for 105. I is the equivalent value for this one. Don't get confused. So just it is now 100 I have given. The equivalent number for this is going to be D. Okay. So meaning that it started from 97 or around. It is going to start with the letters A. Right? 97 is A, 98 B, 99 C, 90. 9C, 100 is D. That's what the output we see when we convert. So character to integer, these conversions is possible. So the char to byte, okay, char to byte is possible. Char to byte is possible. The range of elements char is going to take 2 bytes, right? It's going to take 2 bytes. So a char data type can be converted into byte or short. Okay, byte or short. But if you have an integer value to be converted into char, then you must be doing explicit typecasting when the integer value is within the range of byte. So okay, that is what you have to ensure. So that is all about typecasting is. Okay, char can be converted into byte. Okay, char can be converted into short. Okay, and the reverse also. So short, long, or any of these types can be converted into char. But only the thing is that this underlying value should be within the range of char type. Okay, 2 bytes, within the range of 2 bytes. Then you can do that explicit typecasting. Okay, this is all about data types and typecasting. Okay, we'll continue in the next session remaining stuff.